All right, welcome everyone. Let's just jump right into this explainer. Today, we're demystifying standardized math and proving that hitting a solid 70% score, which, by the way, is exactly what you need to hit those elite targets, is totally attainable. You just need the right toolkit. We're going to focus heavily on the real game changers: algebra, quadratic equations, factoring, the discriminant, and a brilliant back-solving strategy that will literally change how you look at word problems.
So here's our attack plan for today. We've got 5 parts: mastering the math game, factoring and quadratic equations, decoding the discriminant, estimation and elimination strategies, and finally, back-solving the rope problem.
Part 1. Mastering the math game, speed versus difficulty. Let's be real for a second. You aren't struggling because the math is impossible. You just need to think systematically and act quickly so you can outsmart the clock. Look at what candidates are actually saying. They always complain about the time, right? Not the complexity of the math itself. The goal here isn't to be some perfect Nobel-winning mathematician. The goal is to process these concepts at absolute lightning speed. If you can confidently hit that 70% accuracy mark through sheer swift execution, you are going to secure your target score. Simple as that.
Moving right along in Part 2, factoring and quadratic equations, building the foundation.
Okay, so here's our starting point for quadratics, the classic ax squared plus bx plus c format. Now, remember, we always set y to 0. And why is that? Well, because we just can't solve for 2 distinct variables, like x and y, at the exact same time. It's a foundational rule. By zeroing out y, we're essentially freezing the equation to find the exact points where our curve crosses the x-axis.
Once we've got that set up, it's time to factor. We're on the hunt for 2 specific numbers. Let's just call them p and q. So for a problem like x squared plus 5x plus 6 equals 0, you need to find 2 numbers that multiply to get your c term, which is 6, and add up to get your b term, which is 5. Pretty straightforward, right? Those numbers are 2 and 3. But here is the trick. Because those factors ultimately have to equal 0, your actual solutions are the exact opposite of those numbers. So your final answers, -2 and -3. Now check out this visual pattern when we compare these 2 expansions side by side. It's like a giant puzzle, but a really simple one. The absolute only difference between the square of a sum and the square of a difference is that one single negative sign in the middle term. That's it. It's x squared plus 2xy plus y squared versus x squared minus 2xy plus y squared. Training your brain to recognize this simple visual pattern on test day is going to save you from manually expanding brackets and wasting those precious seconds.
All right, Part 3, decoding the discriminant, the root of the problem.
So what happens when an equation doesn't factor easily and we need to pull out the almighty quadratic formula? Well, we look at this isolated mathematical sequence right here called the discriminant. It's basically the engine of the entire quadratic formula, just sitting right there under the square root symbol, b squared minus 4ac.
And you know what? This tiny little equation dictates literally everything about the nature of the solutions. If you quickly calculate just this tiny piece, right, just the b squared minus 4ac part, and you get a negative number, bam, you immediately know you cannot have any real values. Why? Because you can't take the square root of a negative number in basic algebra. By spotting this early, you save yourself minutes of complex, agonizing math. You just stop, mark no real solutions, and absolutely breeze on to the next question.
Which brings us to Part 4, estimation and elimination strategies using real-world logic.
I really want you to ask yourself this intuitively before you even think about doing any stressful long division. If you have 1 divided by 1.33 and 1 divided by 1.5, which fraction is actually bigger? Let's think about this using a real-world sharing analogy. Imagine you have a massive amount of wealth to share, say $20 billion. If you share that exact same wealth among a very small group of people, let's say senators, representing our 1.33, versus a massive group of people across the whole country, like teachers, representing the 1.5, the individuals in the smaller group inherently get a much larger slice of the pie, right? So mathematically, 1 over 1.33 is definitely a greater value than 1 over 1.5.
So, why does this matter for the exam? Well, knowing that the first number is bigger means if a test question asks you to subtract 1 over 1.5 from 1 over 1.33, your answer absolutely must be positive. You're taking a smaller number away from a larger one. Using this estimation hack is a huge game changer. It lets you instantly eliminate any negative multiple choice options without writing down a single calculation on your scratch pad.
And finally, Part 5, back solving the row problem, working the options. Okay, we've all seen word problems like this one. A rope 40 feet long is cut into 2 pieces. Now, instead of panicking and trying to construct some messy algebraic formula where x plus 18 equals 40, we're going to use an incredibly powerful elimination strategy. It's called back-solving. Basically, we're going to let the multiple choice options do all the heavy lifting for us.
So, the golden rule of back-solving is to always start by testing the middle answer choice. Since test options are usually in ascending or descending numerical order, testing the middle number immediately dictates whether your next guess needs to be higher or lower. It completely narrows down your possibilities in seconds. Let's see this in action. Say the middle multiple choice option is 18. If we guess the short side of the rope is 18 feet, well, the problem states the long side is 18 feet longer. So, 18 plus 18 makes the long side 36 feet. Add them together, 18 plus 36 makes the whole rope 54 feet long. But wait, our rope was only 40 feet. Because 54 is way too big, we immediately know our initial guess of 18 was too high. That means our next guess must logically be a lower option.
So, by smartly adjusting down, let's test a lower option. Let's try 11. If the short side is 11, the long side is 11 plus 18, which is 29. And would you look at that? 11 plus 29 gives us exactly our 40-foot rope. We just found the correct answer, and we successfully bypassed the complex algebra entirely. We just tracked the possibilities until we found the perfect fit.
You know, standardized tests aggressively reward this exact kind of systems-level tracking and elimination over brute force calculation. Whether you're using the discriminant to skip dead-end equations, using logical estimation to slash negative answers, or back-solving the conquer word problems, it's all about working smarter, not harder. So I'll leave you with this challenge as you continue studying. Are you just trying to memorize textbook formulas? Are you finally learning to truly think in systems and possibilities? Thanks so much for joining me on this explainer, and I'll see you next time.